So this particular problem can be used as a basic problem to look into the projection. So here we have a question that goes like, a body is projected at such an angle that horizontal range is 3 times the greatest of height. Find the angle of projection. Okay, so we'll start with the problem. Given data, your range is 3 times the maximum height. So this is what they have given. Next is, we'll use the formula for your range, we'll use the formula for your height, just substitute it in the given data, we'll be able to find the angle of projection. Okay, so this is the formula for your range, u square sine 2 alpha divided by g, and your maximum height is u square sine square alpha divided by 2g. Okay, your alpha over here is basically a angle of projection. Just substitute it in the given equation. So here, once you substitute it, obviously you will be able to find that your u square will vanish off, g again will vanish off, but here you're comparing sine 2 alpha and sine square alpha, okay, which you cannot do any sort of mathematical formulation. So what we are doing is, we are looking into a small constraint. Sine 2 alpha is split up and then it is just written as sine alpha cos alpha. This is your basic trigonometry. Okay, so once this is splitted, sine 2 alpha is splitted up, then you can write it as sine alpha into cos alpha. Now it will be very much easier. So this sine alpha will vanish off, just remaining the term is sine alpha over here. So this term is what you will be having. I missed a 2 over here, and here again you're going to have this 2 term. Okay, it's sine square sine 2 alpha is 2 sine alpha cos alpha. Okay, so here again I missed this particular 2. Please make a note when you're doing it. It is u square 2 sine alpha cos alpha. So if you just simplify this, you're going to get to this equation. Now the only unknown term is alpha, which you can find it out when you're simplifying the equation. So you just bring this cos alpha over here and your 1.5 over here. So it is tan alpha, sine by cos is tan alpha, 2 divided by 1.5. So tan alpha is 1.33, alpha is tan inverse of 1.33, and alpha is 53.13 degree. So here again, please make a note, sine 2 alpha is split as 2 sine alpha cos alpha. Hi again. So in this particular video, again we look into a much more complicated problem related to the projection or projectile basically. So we'll start with this problem. A particle is thrown with a velocity of 5 meter per second. Okay. So what they have given over here is this 5 meter per second, which is the velocity u, the angle of inclination or elevation alpha, and it's told us alpha is with respect to the horizontal. Find the velocity of another particle thrown at an elevation of 45 degree. So we'll take it as alpha 1 and u1 over here, u1 and alpha 1. So this I'll consider as alpha 2, right? So you're supposed to find out what is your value of u2. So they've given us the condition, both these u1 and u2, first condition and the second condition, will have the same range. So which means r1 is equal to r2. Next condition, maximum height, so which is h1 is equal to h2, and last is your time of flight, so which is t1 is equal to t2. So you have these three conditions, condition number 1, condition number 2, and condition number 3. For these three conditions, find out what is the value of u2 separately. As simple as this is the problem. Okay. So u1 is the velocity of the first particle, 5 meter per second. Alpha 1 is the angle of projection of the first particle. u2 is the velocity of the second particle, and alpha is the projection of the second angle of projection of the second particle. So when both these particles has the same range, you will be able to find that. I'm just substituting what is the value of your range, formula for your range. So u square sine 2 alpha 1 divided by g, and u square sine 2 alpha 2 divided by g. So here again, you have what is the value of your u1. So it is phi square, and your alpha value is known to you. Sine of alpha 1 is 60, so this is 2 alpha, so it is 120 degree, and g again you can just cancel it off, so no need to worry about that, is equal to u2 is the one that you have to find. So u2 square sine of alpha 2 is 95, so 2 alpha 2 is 90. So basically you have to find out your u2. So u2 is equal to phi square sine of 120 divided by sine of 90. Just take a square root of that, you are going to get this value. Okay. Next, when both the particles have maximum height, this is the formula for finding out the maximum height. Here again 2g can be taken off. So here you have, let me just write it over here, phi square sine square alpha 1 is 60 is equal to u2 square sine square 45. So what you are requested to find is u2. So u2 is equal to phi square sine square 60 divided by sine square 45. Just take a square root of this, you are going to get to this particular value. Okay. So we have found out this first statement as well as the second statement. We'll get to the third statement. So your third statement is time of flight is same, t1 and t2 are same, so I can just remove this off, and finally you can find out what is the value of your u2. So with this we'll end your problems. Please look on to this. Thank you.